Hi everyone and welcome back to the channel. In today's video I will use SOLIDWORKS xDesign to change an assembly I created for my guitar gear to adapt it to the gear of one of my subscribers. In my last videos I created a box to carry my wireless guitar transmitters safely without risk to damage them. I started from actual dimensions and created some parts to protect them and a box around those parts to carry them safely. This project interested one of my subscribers, Mark, who had a similar but not the same gear, so he asked me if I could help to create a custom one made for his transmitters. Because we live in different continents, I proposed to create a 3D printing file he could print at home, and he agreed. So we need dimensions. As I said, gear is similar but not the same, and the goal is the same as in my last videos. I don't want damaging his gear at all. As you can see, Mark has a caliper and did a great job at taking all the measures for me. He also created a blueprint with AI to display them. That will be very useful. Thank you, Mark. First finding, they look similar, but they absolutely won't fit into my 3D printed parts. So there will be some real changes. So I start from the assembly I created for my transmitters, but I also want to keep my parts in case I want to print them again. So I use a new branch to create a new version that I can modify without changing my part dimensions. Don't forget to open the new version and you're ready to make the changes. Now I've got a brand new model and I will change dimensions to match the ones provided by Mark. I will start by the main shape and I will also remove drafts as his gear is straight. Here I directly enter the values provided and you can see how it's different enough to need a new casing. Depth is also a little bit different, so I change extrusion in one direction and remove drafts. I also need to remove fillets, but you need to make sure you choose delete selected to keep the rest of the features. You may be in trouble if you don't. Then the rest is just updating a reference that changed in this sketch. I remove the reference and add a new one. This is very straightforward. Next, I check fillets to make sure they are correct. First one is okay, but on the second one, because I remove rounded corners, there is no tangency to handle all the needed edges. So I edit the feature and add all edges I want. For the next plane, this is a little different. Because the parting line I used as a reference doesn't exist anymore, so I have to select a new reference to offset the plane by 0.5 mm to be accurate. For the tombstone shape, again, some references have changed, so I replace them with simple references. When I accept the feature, I realize direction was defined another way, so I change it. Last features rebuild correctly, so I can save and move to the casing parts, the parts that will contain the gear, and that I will build around it. When I edit the first sketch, you can see dimensions that were perfect for my gear are not adapted here. So I measure by selecting entities and pressing M key for measure. I realize part is very close under 75 mm, so I change sketch dimension to 75 and keep the thickness. I also measure width, but this time part is narrower. So I update dimension from 40 to 37 to keep some clearance and reduce outer value to keep the same thickness too. Once the part is rebuilt, I make sure I display the right set of features in the feature manager on the left, and I roll back the rebuild bar on the first feature. This way I will be able to follow the build-in feature by feature. After the sketch I just changed, I continue with draft angle because I want to keep room. Then I edit first cavity and change the starting plane so it is exactly where I put the plane on the part above. The rest rebuilds without any error. I can save the model and proceed to the second cavity. As soon as I do that, there is an error in the first sketch, so I use sketch analysis that xDesign proposes on bottom right and accept suggestions. This solves the error and sketch is projected correctly from first cavity. Extrusion is now correct, but when I check depth, I see 1 mm missing. Let's change dimension to 11.5 mm. Then I check other features and here we can see that parametric modeling where you define dimensions and relations based on geometry are a real benefit. I check the remaining features and realize this slot is not relevant because Mark's gear doesn't need it. So I just select and press delete on my keyboard. To finish the cavity I add some fillets on inner edges, but they are more cosmetic than useful as the part won't be damaged anyway. Parts are ready, this is printing time. even if I will only send a file to Mark so he can print locally. I will choose STL format for the file. This is the standard format for 3D printing. Because we change outside dimensions of cavity parts, casing will need to be adapted to these new dimensions. To make sure I keep my casing parts secure, I add a new branch on my model. So xDesign creates new independent revisions. This way I will still have access to my parts if I need the new print. First I check I've got the right versions in place. Then I check casing adapts correctly to inner part position. As you can see, casing changes and adapts when I move blue parts. Parametric modeling does that. This is what SOLIDWORKS xDesign does. So I define spacing between blue parts with this mate dimension between 2 points. 2 millimeters seem to be enough. So let's move on. There is obviously an issue, as you can see with the hole here. To find when the problem really occurs, I move the rebuild bar above the hole and see what the problem is. It looks like edges defining cavities lost their reference. As I don't want to spend time finding why, I just delete all the edges and just recreate them from the underlying sketch from bottom part. As you can see, when I select an edge that belongs to a loop, xDesign gives the opportunity to select the whole loop with this icon that appears exactly where I need. I do this for both cavities. Rebuild and problem is solved. Here I detect a peak on the corner. I will solve that later with case dimensions. Now I will rather increase pocket size I created to store charging cable. I found it was too small on the part I created for myself, so I give it another 5 millimeters, first with outside shape, then pocket itself. Done. Then I solve the peak I detected earlier, changing the offset size to give more thickness. Because unfortunately for my schedule, I'm never done improving my parts, and I found the locking system with a magnet was not sturdy enough, I decided to add some jaws. This will be rather simple, teeth on one side, holes on the opposite part. This way there will be some resistance to any shear force. I leverage the thickness I left for the magnet and add a rectangle of 20 by 5 millimeters. Then watch how I leverage geometry to create an axis in the middle of the part. Just selecting the middle point of magnet pocket. So I start with teeth with a draft angle to help centering teeth in the holes when I close the case. Of course I finish with a fillet on top face of the teeth to avoid sharp edges. Now let's make holes on top case. For that I show the top case part and I don't forget to activate geometrical set by double clicking on it. I see it worked because rebuild bar is now displayed next to top case features. I leverage existing teeth geometry to project contour on the other part. And to do that, I create an offset of teeth contour from one part to the other. This way, if I change teeth size or position in the future, holes will follow. I do that for both teeth with a standard offset value of 0.2 millimeters. When I make the cut, I also add this 0.2 millimeters to the extrusion depth to make sure teeth will never prevent closing of the case because it's too high. I also add the same draft angle for the centering and I check everything is correctly in place with a section view. As you can see, there is a small gap that will compensate with 3D printer accuracy, so in worst case it will still work correctly. So now casing is finished and ready to send to Mark for his own printing operation. Actually, Mark printed those files, as you can see in these pictures. Nice, isn't it? The funny thing is that the only small issue was that the parts weren't small enough. So what should we do? Well, my rule is customer is always right, even when it's free, so I decided to solve this issue along with some small others in my next video. We will see how to reduce the size of an existing assembly while keeping important surfaces intact. If you want to try this project yourself, head over to solidworks.com/makers and start designing today for a very affordable price. You'll also find plenty of tutorials and examples to help you get started. Thanks for watching and see you in the next episode.